This is Unit 3.1, Section 4.5 in our textbook. So we're going to talk about dilations, and dilations is a type of transformation where you make an object bigger or smaller. When you make it bigger, we call it an enlargement, and when we make it smaller, we call it a reduction. And we'll know which one is the pre-image and which is the image based on the primes in the picture. So in this example, LMP is the pre-image because it didn't have any primes, and then L prime, M prime, P prime would be the image. The scale factor is describing how much you increased or decreased your picture by. So we're going to determine the scale factor by taking a new measurement and putting it over an old measurement. Now that can either be the actual sides of the figure, like if I knew how long LM was and how long L prime M prime is, I could use those. But I could also use the distance from what they're calling the center of dilation. So if I'm dilating about point C, C to P is a measurement, and then C to P prime would be a measurement. So if the scale factor K is between 0 and 1, it was a reduction. It got smaller. And if it was greater than 1, that means it was an enlargement. It got bigger. K cannot equal 1 because then it means it didn't change its size, and then it's not a dilation. And we're also not going to deal with negatives because that's combining a dilation with a reflection. So here we're going to determine whether the dilation from K to K prime is an enlargement or reduction, and then find the scale factor. So this is K, so that's my original. And here's K prime, that's my new. Or new and old, I should say. I'm going to change that to old because that's the words I've been using. So the distance, let's start here. The shape with K prime in it is bigger than the shape with K in it. So we're going to start out by saying this was an enlargement. Now the scale factor. So our scale factor we're going to find by doing new over old. If I start at the center of dilation and go all the way to the new point, that was a total of 7. And then if I go back to the center of dilation and go to the old point, that was this number here. If that was 5, this has to be 2 to make it 7. So the new number, the old number is really 2. So K would be 7 over 2. We're going to leave our K's right now as the improper fractions. If you turned it into a whole number, or you turned it into a mixed number, or you turned it into a decimal, all of those are fine. But generally speaking, I keep my K's as this. All right, so you go ahead and try 1. You can pause if you like. The answers are posted online. In a dilation, the sides and distances from the point of dilation will be proportional. So that means they're in the same ratio. The angle measures will stay congruent. So the angles will not change their size, but the sides will change proportionally. Each side of the image will be parallel to the corresponding side in the pre-image unless it contains the point of dilation. Then it will be the same line. It'll just be longer if it's a segment, or the same exact line if it's a line that goes forever. So in example 2, we're looking at line AC and line PQ that happen to intersect at point B. We're going to dilate lines AC and PQ to create A prime, C prime, and PQ prime, Q prime. And we're going to center it at P with a scale factor of 2. Since P is part of the line PQ, that line will not actually change. So when I'm looking at my choices here, I'm looking for one that says PQ is the same as line P prime, Q prime. So I can get rid of this and this because neither of those mentions the lines being the same. Then my other choice was my old AC will be parallel to my new A prime C prime, or my old AC will be perpendicular to my A prime C prime. It's going to be parallel because we just learned that each side of the image will be parallel to the corresponding side in the pre-image unless it contains the point of dilation. So because AC did not contain the point of dilation, it remains parallel to its new, whereas PQ did contain the center, so it stays the same line. This is the kind of question they might ask you on the tests you're going to end up taking at the end of May. Rule for dilation centered at the origin. So if we want to dilate a point and I know it's centered at the origin, all I have to do is multiply the ordered pair by the scale factor. So if I'm starting with a point xy, I would multiply by the scale factor of, let's say, 2. So if I started with 2, 3, double them, I get 4, 6. And that's how we get our new point. So in example 3, we have quadrilateral ABCD, and we're given its coordinates. We want to graph the image of ABCD after dilation centered at the origin with a scale factor of 1.5. So if I multiply every single one of these ordered pairs by 1.5, so 4 times 1.5 is 6. 6 times 1.5 is 9. 9. 2 times 1.5 is 3, and now everything is going to be a variation of that. 3, negative 3, and negative 3, 6. So I'm going to plot my A prime at 6, 9, B prime at 9, 3, C prime at 3, negative 3, and D prime at negative 3, 6. All right. Terrible lines, but we'll live with it. So this is my dilation centered at the origin of ABCD with a scale factor of 1.5. It was an enlargement. I know it's an enlargement because this was bigger than 1, and my shape did in fact get bigger. So here's one for you to try. Pause if you'd like. Answers are posted online. Just like we rotated around a point that was not the origin, we can dilate around a point that's not the origin. And we're going to use the same rules we did before. We're going to do SRA, subtract the point that we're dilating about, apply the rule, which is just multiply by k, and then add that point back. So for example 4, I'm going to set this up the same way I had done the other ones. I'm going to write my points out. I'm going to subtract. So I'm subtracting negative 5, negative 2. So minus negative 5, minus negative 2. The first step is always the opposite signs of that center that they're giving me. So this is going to be 1, 3, this is going to be 3, 1, and this is going to be 3, 3. So now I'm going to apply the rule. Scale factor of 3 means I'm going to multiply by 3. So that's going to be 3, 9, 9, 3, and 9, 9. And then my last step is to add the center back. So I'm adding a negative 5 and I'm adding a negative 2. So that means D prime will be negative 2, 7. E prime will be 4, 1. And F prime will be 4, 7. So we'll do another example together. Same idea. I'm going to start with my original points. A little backwards here today. Okay, so subtract. Again, I have 2 negatives here, so we're going to do the opposites. Plus 3 and plus 8 on those. So that gives me negative 4, 12, 2, 14, and 4, 4. Then my rule, I'm going to multiply by 1/2, which is the same as dividing by 2. So that's going to be negative 2, 6, 1, 7, and 2, 2. And now we're going to put that negative 3, negative 8 back. So L prime is negative 5, negative 2. M prime is negative 2, negative 1. And N prime is negative 1, negative 6. There's one last one for you to try if you'd like. The answers are posted online. But that is the end of all of Unit 3, Section 1, Text 4.5.